Hello all, welcome back to my channel. So here grammar is given. We have to prove that the given grammar is ambiguous. Right? So to start with, first I number the production rules. Yes derives ICTS. This is rule number 1. ICTSCS is the rule number 2. Yes derives A is rule number 3. Then C derives B is the rule number 4. Right? So now I'm going to derive the same string by showing two different parses. If that is done, then I can easily prove that the grammar is ambiguous. So to do so, randomly I'm going to derive the string. While deriving the string, possibly I make sure that I'm involving all the production rules. Right. Before that, let us realize what are the variables used in this grammar. Yes and C are the variables because those are written in caps. What are all the terminal set available here? I is one of the terminal, T is another terminal, E is another terminal, A, B. Totally 5 terminals are there. I, T, E, A, B. In fact, this grammar describes the structure of if condition statement. ICTS means if condition then statement. ICTSCS means if condition then statement else statement. So this context free grammar just explains or gives the structure of if condition statement. Okay, fine. Now I'm going to derive a string. I will use LMD, leftmost derivation. You people know what is LMD. Every time replacing the leftmost variable in the derivation process leads you to the leftmost derivation. So first I choose the rule number 1, ICTS, right? Okay. Out of these two variables, let me choose the leftmost variable, which is C. Now in place of C, I replace it by B, IBTS. So C derives B is a rule number 4. I'll write down the rule number 4 also here. Now this is the variable which is left out. Let me replace that variable by rule number 2. IBT, in place of S, I replace it by ICTSES, which is rule number 2. Now again, I just do the leftmost replacement. This is the leftmost variable. In place of the C, I replace it by B. Now, so we are applied the rule number 4. Now we go left to right derivation. So IBT in place of this S. Now let me replace it by A. Yes, it means I have applied the rule number 3. So this is the left out S. In place of this, I replace it by A. So now for the same string, I'm trying to derive another way, or I'm going to find out another way of derivation. Another way of derivation need not be RMD. It can be another LMD also. So let me show you how to do that. So now again I stick on to LMD, but LMD2, leftmost derivation, the second method, let us take. Okay. So as usual, let me write the start symbol. Now instead of selecting the first rule, I go with the second rule, ICTSES. So this is the second rule. I write down the number here. Now since I'm sticking on to leftmost derivation, I have to choose the leftmost variable, which is C here. Now the C is replaced by B, TSES. So which is rule number 4. Now select this S. In place of this S, we have to apply the rule number 1, which is ICTSES. Rule number 1. Now again stick on to the leftmost. Now this C could be replaced by B now, which is a rule number 4. Now this S could be replaced by A, which is rule number 3, and now this S could be replaced by A again. IBTI BTAEA. So the rule number 3, once again, we have applied. So I could be able to derive the same string in two different ways. How do I say I obtained two different ways? The way I have selected the rule. So in the second method, how did I select the rules? First, I have selected the second rule, then 4, 1, 4, 3, 3. This is the order I have selected the rule. Whereas in this method, first rule, then the fourth rule, then 2, 4, 3, 3. This is the order of selection of rules. But I obtained the same string again, but the order of selection of rules are different. So obviously it will end up in two different parse trees. I am not going to draw complete parse trees, just I will show you how I am getting two different parse trees. You people, I hope you people can complete the parse tree construction. So for the first LMD1, I'll draw the parse tree. Yes, it is replaced by ICTS, isn't it? The start symbol here, it is expanded as 4 branches. Then we know that this C is replaced by B. Then this S is further replaced by ICTS, ES, E and then S. Then this C is replaced by B, then this S is replaced by A, and finally this S is also replaced by A, right? Okay, now if I try to draw the parse tree for the second one, my parse tree looks like this. Of course, the root of the parse tree is S, but now this S could be expanded as 6 branches. I, C, T, S, E, yes. So further you people complete the construction of the parse tree. Now just let us compare the parse trees. So look at the parse tree here. In the first one, this S could be expanded here as 4 branches, whereas here the same S could be expanded as 6 branches. So structurally here only the parse tree differs. But at the end we are obtaining the same string. There is no change in the string. You are obtaining the same string. So that's why the grammar is said to be ambiguous. So the given grammar is found to be ambiguous. So now I'll just share you the tips to prove the given grammar is ambiguous. The very first tip is, when you are deriving a string, try to involve all the rules in the derivation of the string, right? This is the first tip. So how this tip helps you further? If you involve all the strings, secondly, you will be getting the option of changing the order of the rules. If you change the order of the rules, obviously you will be getting two different, structurally different parse trees. So it will be easy for you to prove the grammar is ambiguous. Okay students, thank you. You practice this problem. This is very important as far as the exam is concerned. I will meet you in another video. Thank you.